Okay, welcome to the first in a series of exam solutions for projectile motion and SUVAT. Question 3 in the last SUVAT paper showed a situation where two rifles were being fired at the same time. Now we find that both of them are fired from a height of 1.5 meters. Now, we know that means that it will stay in the air for as long as it takes for an object to fall vertically 1.5 meters. And both of them will do exactly the same thing. So both will stay in the air for exactly the same period of time. We're going to get a situation where you're going to combine two motions. The first one is a horizontal motion. For both of them. And the second one is a vertical motion due to an acceleration from gravity. Now, one of these is accelerating and the other one is not accelerating. So here, because we've been told that the air resistance is negligible, on the horizontal axis, on the horizontal one, we know that it will be a constant velocity. And we also know that in the vertical, it's going to be accelerating due to gravity. So we have two different approaches to this one. The first one that we want to try and find out is just how long it stays in the air. And that's part of the question here. Calculate the time that the bullet is in the air before it hits the ground. So the first thing we need to do is find out what information we have and then try and solve it using that information. So the first thing that we always do is we create our list of known information. S, U, V, A, T. Now we know on the vertical axis that as it's moving, it's going to be accelerating. So let's put in what we know. We know that the height is 1.5 meters. We know that the initial velocity in the vertical, not as it's being fired. In other words, vertically speaking, it starts with no velocity, so it starts with 0. Final velocity, we're not really asked for that. We could calculate it, but we don't really need to know that to answer this question. However, we do know that gravity is 9.81 meters per second per second, or meters per second squared, if you prefer it that way. And we are looking for the time. So this is the one that's the question mark. Now just to complete the list. V is not a question mark. V is actually unimportant for this particular one. So we look through all these SUVAT equations. You may want to do this as I go. And we'll find that the equation that we want to apply, I'm going to insert an equation here. Is the displacement is equal to ut plus a half AT squared. Now we rearrange this equation using what we already know, and we'll find that part of this disappears because u is 0. In rearranging this, we end up with being able to avoid that altogether. But we wanted to find out what t is, so rearranging that for t. We find that t is equal to the square root of 2s divided by a. So just substitute the values in for that. You see that that's 2 times 1.5 divided by 9.81. Now typing that into my calculator to get t. Find that the time is equal to 0.55 seconds. Now that's as close as we need to get on that. Now remember, this is true both for the bullet passing from rifle A and for the bullet passing from rifle B. The only distance now is that they now actually travel at distant velocities across to the right. So instead of constant, in order to answer the next question, we need to keep in mind just how long it is that is traveling across the screen towards the right. So how it's traveling in this direction for 0.55 seconds. So knowing that, we can work out how far it goes. So let's look at the next part of the question. Alright, so now we know that it's going horizontally, and we know that it's just using the standard equations for constant velocity. So we know that the velocity, in this case horizontally, is distance over time, or we want to use it displacement over time. If we rearrange that equation, there's I is equal to the displacement. Substitute the values in. And if we go to the top here, we find that rifle A is fired at 430 meters per second as it leaves the rifle. So it's like rifle A we're interested in. Just substituting in the values, we know it's staying in the air for 0.55 seconds, and we know it's travelling at 430 meters per second. Which ends up providing you with a distance of 236.5 meters. Now, I have to take into account significant figures. So let's just look at our little list of information that we have for this. Should usually put this in first. V is equal to 430 meters per second. And T is equal to 0.55. And we're looking for S. Question mark. So here we have two significant figures, and here we have two significant figures. So we're going to round that to 240. So that's the answer to that one. Now the trick to that is just knowing that how long it's actually travelling in the air. Let's have a look at the next question. Next question is looking at explaining why a particular event occurs. So let's copy this question across into our slides and have a look at it. So, rifle B is fired, and a bullet emerges with a smaller horizontal velocity than the bullet from rifle B. Now this is important. Remember, both of these are travelling at different horizontal velocities, but they're both travelling, staying in the air for the same amount of time, because they're both dropping from 1.5 meters. So the way I would explain this in an exam is to say both bullets fall 1.5 from when they are shot. This means that they stay in the air for the same amount of time. In this case, 0.55 seconds. However, bullet B will move a shorter distance because its horizontal velocity is an Americanism. Horizontal velocity is less than that of bullet A. Using the equation S equals V times T. T is the same, but V is smaller. And that's how to solve that question. I hope that's been helpful.